Hi everyone, this is Advanced Statistics for the Social Sciences. In this lecture, we'll continue with the one-factor ANOVA content using the smoking study as an example. So we've already introduced the smoking study again, and this time in this smoking study, we have a researcher who has randomly assigned one of three quit methods to each participant. So subjects are randomly assigned to groups. So the three groups are either quitting cold turkey with no help at all, financial incentive for quitting, or a nicotine replacement therapy. And the outcome, as we've used in the prior examples, is going to be the number of cigarettes smoked during a specified period. So we call that smoking intensity. This is what an SPSS box plot would look like for the groups of the predictor against the outcome. So on the y-axis, we have the number of cigarettes smoked per day. That's our outcome. And then we have these box plots of the different quit methods. And so what we can see from just looking at the box plots is this will give us some preliminary idea of whether we have mean differences across the groups. And so it looks like from just eyeballing these box plots, we can see that the mean for the no help group is much higher than for the financial incentive or the nicotine groups. The box plots, as we've talked about before, they also help us to identify any potential outliers in the data. And we do see that there's one outlier. It's that starred person from the nicotine group, the nicotine replacement therapy group, and it looks like they have smoked a very, very small number of cigarettes in the day that was measured for this data. So that for that person, that particular quit method was really, really effective, which is good, but statistically that person is an outlier, which we know is not the best. So this is what the SPSS syntax would look like. I will go over this with you in class and show you how to get this by point and click. But we've actually looked at this before in using regression as well. And so we use the ANOVA command, and SIGS is our outcome and quit method is our predictor, right? And in the very bottom statement, the design statement, that's where we include quit method as the predictor. So the first output that we get are the descriptive statistics. And the dependent variable is listed as number of cigarettes smoked per day, and they're giving us the descriptives broken out by the groups of the predictor. They're also giving us the overall descriptives as well. So you'll see in the first column where it says quit method, it lists the three types of quit methods: no help, financial, or nicotine, and then also total. And total is saying that this is collapsed over the three groups. Okay. The second column is giving the means. Again, we just looked at the box plots, but looking at the numerical means as well, we see that the mean number of cigarettes smoked per day for the no help group is a lot higher than the financial or the nicotine groups. Okay. We've also got the standard deviations and the sample sizes per group and the total sample size, 15 participants. The next output we are going to look at is the test of between subjects effects, or the ANOVA table. Okay. Now there's quite a bit more information in this table than when we are used to looking at the ANOVA table from regression output. But I'll kind of go through and highlight what information is pertinent to us and what's appropriate to use when we want to report information on the sums of squares and the degrees of freedom and so on. So in the analysis of variance model, the results from the model basically say that quit method determines some part of each score. And so the results from this model tell us whether quit method impacts the scores via the group means. So we're going to get information from about the types of methods such that here we would think that effective methods would have lower means and ineffective methods would have higher means, right? Because ineffective methods are going to result in more cigarettes smoked per day on average. Effective methods are going to lower that number of cigarettes smoked per day. So on our outcome, each score is going to contain some group effect of how the group influenced the score. And then there's also going to be some leftover error component. And that's that variability that we talk about having in the scores that could be due to some other unmeasured predictors we have, or just kind of random variability and individual differences across the participants. So let's talk about how the variability is going to get partitioned in this model. So in this example, we have the distribution of scores, and that is represented by the red bell curve across cigarettes, which is our outcome, number of cigarettes per day. And I've highlighted here one score, an individual score, and this person had a score of 19 cigarettes per day. Okay, so that's where you see y sub I is equal to 19, that little score that I've highlighted. Then I've also put here a vertical bar at the mean. And so when we looked at the descriptives, the total mean for all participants was 10. So on average, all participants smoked, across participants, they smoked on average 10 cigarettes per day. So the mean is highlighted here as well. And then I've also highlighted this variability, which is the difference between a person's observed score and the mean. So the mean captures some portion of the score, but then there's this leftover part that's the difference between an individual score and the mean. And I've highlighted that here with this green horizontal arrow. And so we see that the deviation between this person's observed score of 19 cigarettes and the mean of 10 is positive 9. So the variability in scores can be further broken down because we have to take into account the predictor's group effect. So this person is assigned to some certain group, one of the quit methods, and then that group is going to have its own mean as well. And we looked at the mean scores on cigarettes smoked per day, broken out by groups, and it looks like this person was in the no smoking group because the no smoking group had a mean of 15 cigarettes per day. So what this shows here is there's a deviation between the overall mean and the group mean. We can see that that deviation is 5, positive 5. That's the difference between the actual overall total mean of all scores of 10 and the group mean of 15. So there's some predictor group effect. And then in addition, there's leftover error variability. So there's the deviation of the score from the overall mean of 10. There's also the deviation of the individual score from its group mean. And here we can see that that deviation is the difference between 19 and 15. So that deviation is 4. So there are sort of several different deviations in scores that we have to take into account to look at how the overall score is partitioned in terms of variability. So along these lines, let's take a look at this general score decomposition and how we break out a single observed score in terms of variability and the means. So the way that we read this equation is let's start at the left and move to the right. So on the left, we're looking at y sub I, which we know is any observed score on y. And that score is equal to these sort of different parts that represent deviation. All right, so we've got the grand mean, and we know here in this example, the grand mean is 10. And then it's the grand mean plus this between group deviation. That's the predictor effect. So that's the difference between the group mean and the grand mean. And here we know that that would be the difference between 15 and 10. And then we, in addition, we add the error or within group deviation. And so that's going to be the difference between the observed score and the group mean. And so that is going to be the difference between 19 and 15 here, and that's going to be 4. So this is kind of how the general score decomposition happens. We've got a single score as being equal to the grand mean plus that between group deviation plus that error deviation or within group deviation. So now let's take a look at these plots again, keeping this overall score decomposition in mind. So first we've got this predictor group effect, and we're going to kind of build this equation from the score decomposition. So you'll see this equation on the upper left of the figure where we have the observed score as equal to the grand mean plus the distance or difference between the grand mean and the group mean. And so in our example, that is going to be 10 plus 15 minus 10, which we know is 5. And then for the leftover error variability, we're going to add to that equation the difference between the observed score and its group mean. And again, that's the difference between 19 and 15, so that is 4. So we can see how this score is the sum of these different means and then the difference between the means and the difference between the score and the group mean. So that concludes the second lecture on one-factor ANOVA. And in the next set of lectures, we'll continue discussing variability partitioning in one-way ANOVA and also overall model significance testing with the F-test.